I find most underappreciated in, and this is not unique to AI, I'd say this is like in every customer facing engineering, is an understanding of opportunity cost. And what I mean by that is for everything that you are currently working on, there's probably that means 20 things that you're not.
Mhm.
And the other way to look at this is that like in a given quarter or a given year, you get so many kicks at the can with a certain team size. And so that's not an infinite thing. And so you want to make sure that where you are spending time and energy is where you think is going to be the most valuable place to do that. And by valuable here, I really mean like business value. So I mean like it's delivering the actual value to like our customers and ultimately impacting the business in a positive way. And so that's a very hard thing to do. And especially, like I said, there's high degrees of uncertainty. So
Yeah.
what I do and what our team does is we're constantly asking, are we working on the right thing?
Hello, everyone. Welcome to another episode of the F10 podcast. This is your host, Deborah, and today we are joined by Thomas Levi, Senior Director of AI and ML at AgLoft. So, Tommy, it's awesome to have you with us today. Welcome to the show.
Thank you very much.
Tommy, do you want to introduce yourself to the audience so that people get a sentiment of your background and stuff before we dive
Uh,
in?
I would be happy to. So I'm Tommy Levy. I am originally from New York City. I live in Vancouver now. I started life as a theoretical physicist doing string theory. I did my undergrad at Dartmouth, my PhD at UPenn. I then did postdocs at NYU and UBC, wrote a whole bunch of papers, and then for various reasons decided to leave academia, go into industry. Data science and machine learning were sort of, well, especially data science was a new and emerging field. That was about 2012, 2013. I started out as an individual contributor working for Plenty of Fish, the dating site. I did that for about 4 years. And then I've spent the last probably 9, 10 years at various SaaS companies, uh, leading, building teams that are really focused around machine learning, especially customer facing machine learning and AI features. And I currently work at Agiloft, where I am the senior director of AI and ML.
That's super cool. So, Tommy, before we dive into the technical stuff, we have a little bit of a tradition on this podcast. It's almost like an icebreaker, but what has been the most memorable meal from your recent past and why?
Uh, I would be remiss to not mention the meal that I proposed to my now wife in, which was a couple of years ago. I did it on our uh, like anniversary. I surprised her, and I had this entire thing planned and did not account for the fact that I was in public when I was doing it. So when I put the ring on the table, I was suddenly very, very aware that everybody was looking at me in the restaurant and so on. But I managed to get down on a knee and propose. She, of course, said yes after actually breaking into tears and stuff. And so I don't think I'll ever forget that. I'm not sure I can remember what we ordered. It was at a charcuterie like wine bar where we actually had
Yeah,
our first date. So it was kind of a good full circle thing. But yeah, that's pretty memorable.
that's awesome. And that's so thoughtful of you too. Nice. Okay, I think whatever I follow this up with won't be as exciting, but I'll try my best. What are the fun challenges that you have been working on recently?
Yeah. So for people that don't know, Agiloft is a contract lifecycle management company or CLM. And so that means we do a lot of work handling our customers' legal data, legal documents, and things of that nature, as well as their workflows. And so in the sort of like machine learning AI space, there's a few different streams of work that we have going right now. One of them is that when people upload their contracts, they really want to understand at a glance what are the important aspects of those contracts. So we have a roadmap of what we call labels and key terms for clauses. So an example would be like an NDA clause or a termination clause. And you want to be able to find where that is in a given contract really quickly without having to necessarily read a 40-page contract every time you want to find where that is. And there's roughly like 200 to 300 of these sort of labels that you care about. And so one line of work we have is really about using natural language to study those contracts and essentially build models to identify all of those labels and extract the key terms would be like, for example, what's a termination period? Is it 90 days? And actually extracting the 90 days. And so we have some labels that we've built successfully that our customers are using, but we're trying to build more. And so that is one large line of work that we have going, as well as working on the underlying machine learning models that power those like per label models. Our other main line of work we call sort of like under the Gen AI like umbrella, and that includes a whole slew of things, some of which I can't talk about yet, but one of our sort of like most recent ones is we call it redlining. And so the idea of redlining is for anyone that's ever dealt with any kind of contract before, you know that usually there's quite a lot of back and forth between lawyers. Even if you've just signed an employment contract, you don't like a clause inside. And generally speaking, lawyers for a given company, let's say being in-house counsel, will have this concept of like their standard language for a given clause or type of thing. And oftentimes when they receive a contract, it's not in that language. And so traditionally what people will do is try to like just drop in their standard language or do find replaces and all this kind of stuff. And that's called a red line. As you might imagine, that then gets sent back. That doesn't match their standard language. It goes back and forth quite a lot. So what we're doing with redlining is actually taking the existing language, their standard language, and using Gen AI to try to blend those together, as well as summarize the changes that are made for those people so they can see exactly what was dropped in, what changes were made in like sort of a bullet point outline form. And they can do that either from their standard language, or they can treat it almost like a paralegal or an assistant. And they can say, take this clause, but for example, add pandemics as a reason to like end this contract or something like that. And it will then take the standard language and put in pandemics for you and summarize that for you. And then we've got a whole sort of long roadmap of features of that nature that we're currently working on.
So the main user for some of these things that you're working on would ultimately then end up being the in-house counsel on the other side.
It's a variety of personas. So definitely in-house counsel. It could also be a lot of people on the procurement and business side. So for example, when I talk about contracts, there's a whole bunch of different contracts. So they might be vendor contracts. Like for example, we use Miro at Agiloft. So we have a contract with Miro and there's some standard language there and so on. Like and everybody else, especially if you're on an enterprise contract, you're negotiating various terms. Also employment contracts with your employees. So all of those sorts of things. And so there's a whole variety of people from people in human resources, people in like business operations, accounting, finance, as well as in-house counsel that are using these things, as well as possibly like IT professionals and so on. Basically anyone that's dealing with any kind of negotiation, either with an employee or with any kind of third-party vendor or something like that.
That's very cool. When you're using a lot of this or building some of these Gen AI based products, how do you deal with the sometimes non-deterministic nature of the software?
It sort of depends on what we need out of the feature, right?
I see.
And so there are some places where, for example, when you're generating content, where you don't have to be exactly the same all the time. Like you can be, I would say, like stochastic, not deterministic, in the sense of as long as you're mostly in the right place, you're fine. There are other places where there is like a clear right answer. Like if you're performing a search and you want to know how many contracts are assigned to me that are currently going to expire in like the next 2 weeks, like that's a number that's not up for interpretation. And so when we're dealing with generating content, then obviously we allow for a little bit more leeway. When we're dealing with something where like we need either there is a right answer or we need it to constantly be like always give the same answer. There are various ways of doing that. So like if it's a third party LLM, there are various hyperparameters. Like for example, you can set the temperature to 0 or something like that. If it's your own LLM that you're running on your own software, then yeah, you can set temperature to 0. You can also, if you're doing a beam search or something like that, you can control that. You can even do things like specify a seed, so that like, even though it's not necessarily deterministic, you forced it to be deterministic. And that sort of depends on a per use case thing. Definitely one of the hardest things we have is, especially when you're generating content, and in the legal domain where like it's very specific language and there is a notion of right and wrong, is determining like, is this thing, like, how is this thing performing once you've built a model? Because it's not as easy as just, yes, no classification all the time. A lot of times it's like, I've generated this NDA clause. Is this something that, would sort of pass a smell test with a lawyer, not just plausible, but actually right? And that is a very difficult problem, which we have to put a lot of effort into.
Okay. So I know you had mentioned a couple other things the last time we were chatting. Tommy, they were in two basic classes is what I realized. One is the software engineering principles and how that applies to AI, ML engineering teams. And the other is generally how DS or data science teams look at the SDLC. I'd love to understand both of those from your perspective, like the normal day-to-day engineering processes as we are building our normal front-end, back-end type of apps. Is there any correlation between that and the day-to-day for most ML teams?
I would say yes. And this is something that's definitely evolved for myself throughout my career. When I first started, I was kind of like, especially coming from an academic research background, I was very much like machine learning, AI is that's like sort of like this special unicorn that, needs its own processes and won't fit into sprints and all this kind of stuff. And I've since sort of come around to not believe that. What I think is that everything that you do for normal software engineering best practices, especially what I would call agile in spirit, you can absolutely do and is a really great way to do machine learning and AI development, especially if what you're focusing on is customer facing, because at the end of the day, you're trying to build a feature for a customer to use. Yes, it's got some AI in it, whatever that is, but it's still all the normal principles of building a good feature still apply. And so what I find is different or tricky with, especially with ML/AI, is usually the level of uncertainty and risk is significantly higher than for many what I would call normal, non-AI features. And what I mean by that is usually, not all the time, but for most companies, especially most sort of startup mid-sized companies, you're not trying to reinvent the wheel. You're not trying to do at a technical level something that's never been done before when you're building out a normal feature, right? There's exceptions here, like if you're Google when it first started and you're trying to index the internet and things like that, that's a different story. But most companies are not trying to do that. And so that like what you're trying to do is, from a technical standpoint, sort of a solved problem. It's how you're going to use all these different pieces, how you're going to assemble the backend, how you're going to connect it to the front end, how an end user is going to use it. That takes work, but you're not worried about, can I do this or not? Whereas in some of the ML/AI things, you may be worried about that. So for example, we may be trying to build a model to identify a certain clause, like I mentioned before. Nobody's ever done that before, or we're not aware of anyone that's ever done that before. And so we have good indication that that's possible, but we don't actually know. And so what that means then is that normally you'd say, okay, well now how do I fit this into a sprint? This is impossible to do. But what I found is that you just basically need to quantify your risk and your uncertainty and be really, really explicit about where you are in the software development process. So for example, we'll start with research and discovery. And really the goal there is just to establish, can I do this? And also like, can I do this in a way that's going to be valuable and feasible and all this kind of
Yeah.
stuff. And so we may do activities in the initial sprint, like explore two different prototyping strategies for building, like, algorithm one, algorithm two, approach one, whatever that is. We
Yeah.
may even start with a literature search as a sprint. So like half a sprint might just be like somebody reading a bunch of papers and then coming away, like the goal at the end of the sprint is to come back with a report with suggestions for approaches we can take. And eventually, as we learn more, we start lowering and shrinking those like error bars of uncertainty and getting more and more knowledge. And then as you condense it more, it starts becoming more and more like typical software development, right? Where it's like, okay, now we know like we're going to use this third-party LLM with this fine-tuned model or whatever it is on this
Yeah.
infrastructure. And now we have to build it and optimize it and make sure it's like production ready and stable and all those sorts of things. And so what I found in that process is really that like it's very important to establish like at each level, what are you trying to learn? What is your biggest uncertainty? What are you trying to learn? And then where are your decision breaks? And make sure you allow yourself to say, this is not going to work. And as soon as you do that, then actually you can use normal sprint methodology and all that kind of stuff. So at the end of the sprint, our goal is not necessarily feature fully delivered or anything like that. It may just be, we want a go, no go decision as to whether or not we should continue development on this feature based on how likely we think it
Yeah.
is to be achievable. And we've done that. And there are models that we've done both at a current company and past things where we've spent a sprint or two investigating and then said, look, this is way harder than we thought it was going to be. Or current technology is not there yet and we drop it. But we drop it in 2 weeks instead of spending 6 months
6
doing
months on
research on
Yeah.
it. And we move on to something else. And so in that case, again, I really feel like it's the same as any other software feature that you're
Yeah.
building.
Yeah, because that agile methodology that you were talking about, that's essentially getting enforced here as well, right? You want sinking a bunch of time into something and you're failing fast ultimately.
Exactly.
Yeah.
And when I say agile in spirit, what I really mean here is like there's 8 million different ways of running agile at this point,
Yeah.
right? I've done Scrum, Kanban, Scrum Bat, like whatever. It's less important that like what specific details you pick. It's more that you pick things that are working both for your individual team and within the company. So for example, right now we do Scrum because that's when I came in, that's what product and engineering we're working with. And so it made much more sense because a lot of the work we do is cross team and cross collaborative to align with them rather than try to do our own process and then sort of, square peg round hole it into them to try to get them to work with us. So you really have to kind of look at the overall picture of like who's on your team, what's their level of experience, how are they doing work, how is the rest of the company doing work, what other teams do you have to collaborate with, and all of that kind of combines into like what your process is. And I'd say the last thing I would say about that is like I don't regard process as a fixed thing. The one thing I always say we have to do is retros, because I think it's really important for the team to constantly be inspecting what is working really well from a meta process level and what is not, and constantly adapting. And that can be major things like should we switch to Kanban, or it can be minor things like, hey, like this mid-sprint meeting we have is not useful, let's get rid of it. Those are all fine, but you should constantly be asking yourself, how can we do this better? Especially as you're bringing in new people are getting more senior, more experienced, that sort of thing.
So I think this actually leads fairly well to my next question, which is around how the SDLC looks like for data science folks. And I know we were talking about this, right? Like there are areas of software exploration or like figuring out what tools to be used to solve this business problem. Then there are issues around data lineage and data provenance, and then ultimately shipping software. And you were mentioning that a lot of tooling isn't really that advanced for the data science population today. So I'd love to dive into that a little more.
Yeah, I mean, I would say that. And I think it's funny because I'm actually giving a talk on this soon. To me, I think it really boils down to that everything you do in machine learning and AI at every step in the SDLC is really, really intimately tied to the data that you're working with. And That is to me, I think, the main difference between doing like a non data driven AI feature. And I can expand on that a bit more. So, for example, if I'm doing let's take that redlining example that I just talked about before. A non-AI version of that would simply be, like I'm just going to replace language into like a Word document. So I have a Word plugin, and I'm just going to highlight the changes and so on. And so what kind of stuff would I need for that? I would need a few contracts of basic data. I would, specify what my use cases are, what the expected behavior is. I develop it locally on my machine. And then once I go into production with that, really what I'm worrying about, like going through, like, let's say staging and load balancing and testing and all that, is load, like can it scale up to whatever I need? Like if there's going to be, 2,000 people using this concurrently, whatever it is, will it scale to that? And edge cases, right? So like, what if somebody has this version of this, or they're doing it on their phone, or, they're the thing that there are no replacements, their language matches exactly to what they want to drop in. Like, is it going to break that? Like all of those sorts of things. And if I do that, great. Now I want to look at this as an AI feature, right? So what do I need? Well, now I want to start, let's say, generating content for this, for like a new clause and things like that. So now I need lots of examples of contracts, standard language, changes that are made. I need someone to mark and annotate that data set and say like good changes, bad changes, this is acceptable, this is not, all of those sorts of things. And I need to keep track of and version all of that. Because if I'm testing, let's say like 6 or 7 different models or approaches that I'm doing, I can only compare those things if I'm comparing apples to apples. If I take like some data and train this model on it and run it off some other test data, and then some other model over here is running off some other data, and then I want to compare them, how am I going to do that? Right? They're on totally different data sets, or they overlap, or all these things. So you have to be really, really careful with that. And then like, let's say I've got a model in production and now I have a new model that I want to compare against it. I better know what data this was trained on to compare the performance of those things and so on. So that's one bit. Now, the other thing is usually, like if you're any company like Agilent, we can't train on proprietary customer data, right? So we have to either synthetically generate, or we have to look at open source data, things like that. But then when you start moving it towards production, right? So now I want to move to, like, let's say staging. So staging might be a subset of customer data. So the performance of the model is going to be different on that data than it has been on the training, whatever I used for training and testing during development. So that's going to look different. And now I have to account for that. As I start moving it into production, like full production, how it actually behaves on customer data. Well, like what happens if my customer data is actually very different? Like I have high skew between training and customer data. Do I want to deploy that to my customer base and potentially have them for a day or two have horrible results? Am I going to wreck trust with my customer base by doing it? So how can I put it into production, see how it's going to perform on customer data as I'm ramping it up, but not negatively impact the customer experience? And these kind of questions all tie into the fact that at every step of the SDLC, the data cannot be separated from the model or the feature. They come together as a package. And then even once it's in production, I have to monitor it, because what's a contract today is not going to be necessarily the language that's used in a contract next year. And so there's drift, and I have to account for that. And I have to know when I need to update my models and all of that kind of stuff. And all of these are things you generally don't worry about with a non-AI feature. And so it sounds like this huge amount of stuff, but really all it comes down to at the end of the day, the essence of it is, are you keeping track of the data and tying that to the model as you move through it? So if you think of, I'm moving a model from one stage, from let's say development to staging to testing to production, at the same time, I also have to be worrying about the data that's moving along with that model and evaluating not just does this work, but how has it changed at each level of data that it's being exposed to? And is that still within my bounds of tolerance and performance and so on? And so that's, I think, a place where there is tooling around this, like and exists. Like go to your favorite cloud provider. We use AWS, but I've also used Google, like Vertex AI and things like that. And they have pieces around this, and there's lots of open source things like Kubeflow, and there's lots of third party
Yeah.
things you can pay for, like Weights and Biases or Databricks and things like that. But I haven't seen anyone make this really easy yet. And then you still want to bring in like normal CI/CD. Like I want to do unit testing, I
Of
want to do
course. Yeah.
integration testing, I want to do load balancing, all this sort of stuff. And combining all these things together in one neat package, I mean, I'd love for someone to tell me,
Yeah.
here it is, and I'm happy to use it. But usually you have to sort of cobble together these different pieces. And so I still think we're not quite at the level where it's like, um, there's a version of like
Yeah.
Jenkins that you can just use for everything kind of
Yeah.
thing.
And like, so specifically in your current role at AgileLoft, does the way you have structured your team, has it also helped you ship end-to-end ML
Yes.
features, like the legal team, etc., that you were talking about? I'd love for our audience to also get to hear about that a little bit.
Yeah, sure. So uh, we have at the moment three teams that sit in the AI ML group. Those teams are, for lack of a better, we call it data science. It's made up of data scientists and machine learning engineers.
Yeah.
Uh, all of these teams have like a lead director and manager managing them. And they're the ones who are doing the sort of like R&D development of um, machine learning features, the model building, and then shepherding that through into production.
Okay.
Then there's an MLOps team, and the MLOps team is essentially building out the infrastructure, tooling, and developer experience for us to quickly move from research phase all the way through the SDLC into deploying features into production and supporting features in
Yeah.
production at scale. And as much as we can, we're trying to strive for standard repeatable patterns for these things. So that like once you have a playbook and there's tooling that you can use, we want that to be quick, easy, and seamless. We don't want people to have to spend lots of time worrying about that. We want them to spend most of their time worrying about um, what's the right word? Like all of the difficult features they're trying to build or the machine learning models, things like that. At the same time, they're also working to establish standard data sets, version those, all the things I just talked about there, so that any data scientist can go in and say, okay, I want to build this type of feature. I need this type of data. I know where it is. I know what tools. I know how to access it. I can spin up instances, whether it's CPU or GPU instances
Yeah.
with the right packages. I can do research on it. I can save into a model repo. I can save like
Cool.
obviously normal version control stuff, and then I can move it through the necessary environments from development to staging to production with a standard pattern. So that's what
Yep.
MLOps is really
Makes
focusing
sense.
on. And then I think the team that you mentioned that's somewhat unique to us is we have this team which is called Legal Knowledge Engineering, or LKE for short. And that's actually made up of people that are lawyers and with significant contract law experience, led by someone with significant contract law experience. And the reason we do that is because we're in a legal domain where anyone who's ever dealt with a contract, it's a very, very specialized technical field.
Yeah.
And data scientists, however great they are, and I'm myself included, I generate some content or I look at something and I'm like, it looks like a contract. Uh,
Yeah.
Great. And then the lawyer comes and looks at it and says, well, here's all the things that are wrong, why this would never pass muster, kind of thing. And so we really need that domain expertise for almost everything that we do. And so they work very closely with a variety of people, obviously our data scientists, in terms of training and building models, evaluating performance of models, but also they do a ton
Cool.
of work curating data sets. So when we, let's say, grab these open source data sets, they're labeling, they're annotating, they're commenting on them, all of that sort of stuff. They also do a lot of work with our MLOps team because we build tooling for them to train models without necessarily, so we have like no code tooling for them to build models so that
Wow.
they can do that without the data scientists. We also have our customers can do that as well. And so they're sort of like our first guinea pigs for a lot of that tooling. And so they do a lot of work with MLOps and engineering to build out the use cases, the workflows, like if there's a GUI, all of that stuff, what parameters need to be exposed, what shouldn't be exposed, all of those sorts of things. So if we can make their life easy, then not only can we build our own models quickly, like for all those labels I said, but we can also then, when we build that out for customer workflows, we're confident that they'll be able to use those things.
That is super cool. It's almost like you have your own set of customers that work within the company. And
Exactly. Yeah.
yeah, yeah, that's awesome. Tommy, one question. You mentioned that the MLOps teams, right? They are essentially the ones that are almost, and for lack of a better phrase, they build the golden parts within the company for other people to essentially come and use. So,
Yeah.
are there some initiatives from the recent past that you think is worth mentioning around how the developer experience actually underwent a step function improvement?
We're in the midst of it literally right now. So
Hmm.
MLOps is a team that we spun up in December. Um,
Oh,
they've been at so what we've been working on is exactly the standardization thing, and we've split it up into two primary phases. So phase one, which we call like the offline experience, is really focused around the research and development phase of the SDLC. And so that's all the things where, as a data scientist, you'd be like, or an ML engineer, you'd be like, I want a Jupyter notebook. I want to build some models. I want to explore this. If I find some, like with standard data sets, if I find something that works really well,
yeah.
then I want to be able to like start moving that through the environments for testing, deployment, all that kind of stuff. And so we now so we reorganized our version control, like our Git repos. We've published standard playbooks. We've also published standard tooling. So now like any of our data scientists can spin up various instances in AWS and SageMaker. They can do that. We have clear guides for like how they can explore models, connect to the data, and so on. So that's phase one.
Okay.
And so that's like 90% done right now. And we've also started establishing clear standards for things like, how we're going to do CI/CD around that, how we're going to do version control around that. Um, you know, the repo structure is important.
Yeah.
So there's, for example, like shared library tooling. So you have to figure out like how does shared library tooling play around with individual feature projects and things like that. And if you're going to do imports from one
Yeah.
to the other, none of this is the super sexy side of doing AI, but it's really important to get these details right. The next phase of development here is phase two, which is really about like what we call the online, the deployment delivery side of this.
Right.
And that really goes through a few different phases. So one of these is, okay, from the developer perspective, how are we going to move it through the lifecycle, right? So what environments do we have? Like we have a dev environment. Um, we know we have a staging environment. Do we need a separate testing environment? How does that connect to production? Who has rights to push from one to the other? What are we going to use for CI/CD? What things have to be passed? All of that normal stuff. At the same time, we also have to specify standard patterns for the rest of the application to connect to the machine learning models, right?
Yep.
So how do I there's an app backend. How does that app backend, if it wants a prediction from a machine learning model or content generated, how does that connect? And so we're also establishing their like standard sort of API patterns and contracts, as well as things like load balancing and stuff like that. And the idea is we want to get it to a point where for the data scientists, the machine learning engineers who are building out production, it's just look, follow these directions, deploy an endpoint. We're using things, for example, like Terraform, so its infrastructure is code, all that kind of stuff where it says specify what you need, specify the scaling behavior, all of that normal stuff. Specify what model, what Docker container, Kubernetes cluster, all those parameters, hit enter, that deploys.
Cool.
We take care of load balancing. And then from the engineering side, like the backend engineers, we just say, look, all you have to do is say you need like an asynchronous call with an API contract. Tell us what the requirements are. You're going to send, like this JSON payload. Here's how we're going to do it. And then again, standard patterns around security, encryption, all of that. So like solve it once. And then now it's hopefully easy. And so that's kind of what we're working on right now is that sort of like phase two development.
Now, this is very interesting, right? Because you work in a very complex problem space. You work with complicated infrastructure. Like on the day-to-day operational side, how do you figure out whether you are supporting the team the best in the best way possible? Is there something you look at? Maybe it's the retros. Yeah, I'd love to learn a little more.
Yeah, I mean, it's a variety of things. So, there's sort of like different prisms or lenses that you can look at this through. So one of them, like
Yeah.
where retros come in and one-on-ones come in, is the people side of this. So does all of everyone on the various teams, do they feel like they're able to do their best work? And what I mean by that is, are they feeling like the things that are blocking them are what should be the hard challenges? Like, oh, it's really hard to get an ML model to make, perform on this data set because it's a really hard problem. Not, I can't get this thing in production because nobody will help me, right?
Yeah.
That sort of thing. And so if people are reporting that and they're like sort of enjoying the things they're working on and the things that they report that they find challenging are the right things, then I feel like I'm doing what I need to do for the team. At the same time, I
Yeah.
also look external to the team. So I look at the other teams that we're working with and the other people we're working with. Do the
Hmm.
product managers feel like they're able to hit their roadmap targets? And they're able to deliver high value features by working with us. If the answer to that is yes, and they have good sense of when we can deliver things, and we say something's going to be in a certain release, and it is great, then I know that like we're supporting that. Do the engineering teams feel like they're able to work with us? They understand what we're saying and so on. So I do sort of lots of check-ins with all the
That's
different
awesome.
sort of disciplines and things like that. Then I'll also look at like more objective measures. Like I said, like, at the beginning of a quarter, we said, this is what we're going to do. Did we do it? And I look at that from a few different angles. One is just simply like if we said we were going to work on these features and deliver them, did we hit that? But I also care at the end of the day about the business impact and the customer impact that we're looking for. So if we said like we're going to do this feature because it's going to get this many people to sign up or something like that, or people that use this feature are going to be more engaged or less likely to churn or whatever that metric is, are we actually accomplishing that? And things like that. And so it's sort of on a per feature basis. So I'll look at
Yeah.
all of those things together. And then I'll also look at our momentum, right? So, or I guess agile people would call it velocity. So I want that to basically be going in a good direction, right?
Yeah.
So, if we're doing all this stuff, we're building out standard tooling, we're building out infrastructure, like that takes time. But the net result of that is that over time we should be faster. We should be able to move through each step in the life cycle faster and deliver more with less people. Because otherwise, what's the point of standard tooling? If I could have
Of
just done it
course.
all bespoke. So I'll look at that. And then the last thing I'll also look at is sort of like the tech debt maintenance side of things. So
Oh,
um, uh, if like as you develop more and more features, are you at a place where like it's easy to manage? There's not a ton of bugs. When bugs do
yeah.
happen, it's easy to diagnose them. It's easy to fix them. It's easy to update models, to iterate on features. Or is it every time you're doing something, it's like you have to open up like, Pandora's box of spaghetti code. And like, you have to start pinging everybody in the company because nobody knows who owns what. And this is all really complicated. And somebody wrote this 12 years ago and nobody knows. And it's not
Yeah.
documented and so on. And so I'm always sort of
So,
striving to spend as little amount of time as possible on the maintenance side of things. You're always going to have to
yeah.
spend some amount of time. But that's another place where the tooling and the policies are important. Because if you've got like good policies around code check-in standards, you've got good infrastructure, you're creating things in a modular way so it's clear that like this team owns this piece, this team owns that
Yep.
piece, all of those sorts of things. Then when inevitably things break, it's not a chaotic who does what kind of thing, everybody running around. It's like, okay, well, like this broke, that's this person's responsibility or this team's responsibility. We have alerting on it. They're aware of it. We've got like graceful fail and we've got a fallback. They can operate on this while like we're limping
Absolutely.
along, that sort of thing.
Yeah, because I can see how that modularization also helps in a couple of different ways, right? You have lesser amounts of bespoke cowboy coding happening. You have the same things
Yeah.
being used in a bunch of places, and just life is more efficient that way.
Yeah, and I'd say like that's one of the biggest challenges coming into like an evolving startup, is that usually you'll start with something that a few people coded, and it's kind of like naturally
Yeah,
people are trying to move fast. It's a few people coding it, and so it is usually some kind of giant monolith, spaghetti code, whatever kind of thing. And I don't say that as a judgment. I just mean like
yeah,
if you're trying to go fast and it's a few people and you don't like that's just what's going to happen. And so it's how do you like as a leader, how do I enact the transition to sort of better principles for scaling while making sure that I still support our features that are currently in there,
yeah,
and can continue delivering features on a steady cadence? Because like what I can't do, like if I went to my like CEO and CTO and said, okay, for the next year we're going to deliver no new features because I want to make the perfect platform to build features on, they're going to get rid of me very quickly. And so it's finding that right balance of like, okay, well, like let's do this over here, but at the same time in the background, let's try to improve the overall infrastructure, but
yeah,
not break this. And that is a difficult challenge for sure.
yeah. This is really cool. So, Tommy, like I'm sure in all of our companies, right, we try to do as much as possible with as few resources as and resources. I don't mean that in sense of money, but even the time, the amount of hours we
Yeah.
allocate everywhere, etc. How do you prioritize both for yourself and like for your team on how to on ways of maximizing the overall ROIs?
Yeah, so I'll start with sort of like team and overall thing. And I think
Yeah.
the thing that is I find most underappreciated in, and this is not unique to AI, I'd say this is like in every customer facing engineering, is an understanding of opportunity cost. And what I mean by that is for everything that you are currently working on, there's probably that means 20 things that you're not.
Mhm.
And the other way to look at this is that, like in a given quarter or a given year, you get so many kicks at the can with a certain team size. And so that's not an infinite thing. And so you want to make sure that where you are spending time and energy is where you think is going to be the most valuable place to do that. And by valuable here, I really mean like business value. So I mean like it's delivering the actual value to like our customers and ultimately impacting the business in a positive way. And so that's a very hard thing to do. And especially, like I said, there's high degrees of uncertainty. So
Yeah.
what I do and what our team does is we're constantly asking, are we working on the right thing? And there are sort of like four different types of uncertainty. I'm stealing this from like, I think it's the Silicon Valley product group. There's usually so there's value uncertainty, and that's really sort of like, will if I build this, will customers pay for it and use it? There's feasibility, like can I build it in a reasonable amount of time? There's usability, which is like if I build this, can I deliver it in a way that people can actually interact with it and use it,
Mhm.
right? Like most people can't fly the space shuttle, so space shuttle might be really cool, but if I can't build it in a way that most of my customers can use it, it
Yeah.
doesn't matter. And then there's business viability, which oftentimes people ignore, which is can the business support it? Can I build this in a way that it's like cost feasible, but also like I'm not going to start ticking a bunch of warning boxes on data privacy, legal domain, things like that is really important to think about.
Yeah.
And so I'm always asking like for all four of those things, where are we? And usually when you start out, you're pretty uncertain on a lot of those things. And we're trying to narrow down. And so a lot of our job is to, as quickly as possible, figure out like, should we be doing this or should we be doing that?
Yeah.
And so what I encourage people to fail fast. And so are you like, there's no point in writing perfect production code if we don't even know if this is a thing we're going to do, right? So hack a prototype together. Let's see.
Yeah.
A lot of these things aren't even about coding. If your uncertainty is on value, then what things can you do with like product managers and UX professionals or surveys or looking at like, what data is out there for, are you solving a problem that customers
Yeah.
are interested in? Is this something that people pay for? You can
Yeah.
interview people, you can do fake door tests. There's lots of things you can do. And so we're
Yep.
always doing that. And we have a lot of tight feedback. So while we're developing something, we'll also be talking and running concept tests with customers or people who aren't yet customers, always trying to validate what we're doing. And I
Yeah.
really think it's important to then use not just the engineering data science people, but also spend a lot of time talking to the product managers and the UX people, as well as our product marketing people to be like, does this fit in? And then the last bit at like sort of the highest level is like, strategically, where is the company right now?
Yeah.
Like, are we trying to affect this metric, that metric? What do our investors want? And that kind of, and like fitting all of that together.
Yeah.
On a personal level, what I usually worry about is the thing that I'm doing the thing that only I can do, right? Especially as a leader. So one of the hardest things I had transitioning from an IC to a leader, like first just a team lead and then eventually like a director and manager, was sort of like relinquishing control because I was used to everything I worked on. I knew really, really down to the micro detail and so on. And I really loved doing that. But you can't really be an effective leader, especially if you're leading a large team or multiple teams, if you don't trust the people that you're working with and that are working on your teams. And so if there's something that I think somebody else either can do just as well as me or probably better, because like certainly when we talk about like the legal knowledge engineers or ML, I'm not an expert in either of those two things. If I'm doing things that they can do better, then I'm in the wrong spot. What I should be doing is something that like my unique skill set and my unique position in the company can do. And so it's not like I have like a checklist. I'm just always asking myself, like, should I go to this meeting or that meeting? Can I trust these people? Like if, you know, and so what I try to do is personally deploy myself on what I think is highest leverage, highest risk, you know, most places where like a giant thing could go wrong or a major decision, or where places where I've seen friction between teams or people, and I think like I might be able to mediate and get that back into a good spot.
Oh, that's super cool. Yeah, because that relentless and almost unwavering focus on just the highest leverage activities, I found that to be quite helpful, even in the last couple of years for me over at DevZero. So it's awesome to hear you say that as well. I think we have gone a little over than we had originally intended.
I always talk too much. I'm sorry.
No, this has been absolutely fantastic, Tommy. And thank you so much for coming on this episode of the podcast. And I look forward to staying in touch with you and best of luck on the talk that's coming up.